There we go. My microphone was muted. Wow, I feel... Sorry, my microphone was muted. I was making a video before I started streaming, and I just stopped my microphone while I was finishing up some details. So, good morning. It's still morning. How are you guys today? I'll be here for chatting. If you guys have any questions until class starts, I can take some time to answer them. If not, that's fine. We can just sit here, chill. So the homework is available on UB Learns right now. If you go into week by week content, in week 1, you'll see homework 1 is posted. It is due next week, Wednesday. I'm not gonna go over, well, I ran out of time to go over the homework explicitly today during class. I will go over next week, Monday, more explicitly how to write your homework. I will go through an example problem in the context of what we're learning. That's a little more explicit, but you can start it, you can look at it. It is available on UB Learns. It is due next week, Wednesday, the 10th, by the end of the day. So you have all the way until midnight to submit it. I encourage you to not wait until 11 to do it. But it is available. You have until next Wednesday. And in general, homework will always be due on Wednesday. There might be a couple changes to that at the end of the semester, just when we hit exams. But in general, the homework is always going to be due on Wednesday. So Nick, it's... An interpreter, it depends on what kind of programming language you're working with. I'll talk about that a tiny bit today. An interpreted language like MATLAB just means you can run each line of code separately, independently. You don't need a whole bunch of other code to interact with or to wrap it in. Right now, MATLAB is pretty much just a calculator for us. We're not going to get into more complicated structures until later on. We're going to spend a lot of time looking at variables and what we can do with variables in MATLAB. MProw, if you have completed the participation and challenge activities, then all you have left to do is the homework. That's essentially the flow. You do your Zybooks, you do your homework. You do your Zybooks, you do your homework. That's really it. Until we get to the programming project. Yes. So for these Zybooks assignments, the due dates are listed in Zybooks. So if you go to the assignments tab in your textbook, you will see the due dates. In general, once again, just like homeworks are due on Wednesdays, Zybook assignments are going to be due on Sundays. Week 1, we typically extend the deadline for week 1 to account for some students who have issues getting access to the textbook in week 1, but Zybook assignments are due on Sundays at the end of the day. Homework is due on Wednesday at the end of the day. So you just bounce back and forth through that. But all the due dates for Zybooks are listed in the textbook. I will probably add those due dates into UB Learns. I'll do that today. Remind myself. So MTM, there are no labs. We've replaced them with office hours all week. Just in terms of efficiency, those start next week. At the end of the day, I mean 11:59. To be honest, if you submit it at 11:59:10, I'm not gonna mark it late. So just before the end of the day. Okay. Okay, note, I will put the due dates for these iBooks in UB Learns as well. Okay, so it is time for class to start. Welcome, everybody. We have a lot to go through today, just because I didn't get through that much on Monday, but that's fine. We'll get through a decent amount. You're not going to be behind. So if you open up, wrong one. If you open up UB Learns in week 1, you'll see all the things you are supposed to be going through. So you should be reading through your textbook, doing chapter 1, participation activities and challenge activities. Remember, participation activities you cannot get wrong. So it's to your benefit to do them, to try them, and then try the challenge activities. If you run into any issues, reach out, office hours, email, however you want to. But the chapter 1 ones are pretty simple. Attending lecture, awesome, great, you're here, perfect, welcome. Notice I posted the links to Monday's lecture, so you'll see it posted like this each week. Section G, you guys are section H, so really you can watch either one. I pretty much go through the same material, but you can watch either one. Wednesdays I will post later today, and then start working on homework 1. So here's the link to homework 1. It looks like this. Like I said, I'm not going through it explicitly today. I will focus more on that next Monday, but it is due next week, Wednesday. Okay, so I will look at that next week. I will go through all of the resources you have available to you guys to do your homework, where you can check your answers, and I'll show you how to submit things and what I expect. Today, we are going to go through essentially all the information in the notes. So if you notice under Attend Lecture, there's a PDF posted. These notes, this is what I will go through each week. So I don't have PowerPoint. I converted all of my PowerPoints into notes. So each week you'll have about 5-ish pages that just summarize everything that we're going through in the week. Okay, so hopefully you find it useful. You will have access to this ahead of time, download it, annotate it, however you want to take notes. But there are no presentations, there's no PowerPoint, it's just these notes. Okay, so I will go through this. Sometimes I will talk explicitly from the notes, sometimes I will talk in MATLAB talking about what the notes say. Okay, so it's up to you. Okay, let's get into the notes. So just some basic, starting out, some basic background on computers. Shna Tuba, I can stay after class a little bit and ask that question again at the end. We just don't have time right now. In general, unless we have time, those are types of questions that should be asked in office hours or via email. I can stay after, I believe I can stay after today for a little bit and answer that question specifically. But right now, we got to jump into the material. Okay, so we are doing computer programming. That means we are working with computers, which by definition, a computer is an electronic machine that processes information by receiving data somehow, whether or not that's from audio, from the keyboard, from something, a webcam, speakers, all of that fun stuff. It stores data in memory via the hard drive is where it has long-term storage. RAM and cache is where it does short-term processing storage. It performs calculations using the CPU, and then it produces some sort of output, whether or not that's some calculation you see on the screen, something you hear in your headphones, speakers, some user interface that you're interacting with. Somehow there's some output. So there's input to the computer, processing, and then output. So like I said, the CPU does that processing. The cache and RAM are for temporary data storage during that processing. That's why the more RAM you have, the better, the faster your computer can go. It has more places to store that memory for processing. And then your hard drive, which is your quasi-permanent storage system that you have access to. What I want to focus on is something called the path. The path is the particular file that's stored on your hard drive is going to have a set of folders in order to get to that file. So the path is that hierarchical list of folders. So if you are in Windows, you would look at Find Folders in your File Explorer. In a Mac, you would use Finder. So if I go into my File Explorer here, and I see all the files I have. So if I wanted to go to a specific file, typically you would start at your C drive. So here's all the files or the folders in my C drive. Then in a Windows, I would go to users, then my username, and then, wrong one. Then box. Most of my files are stored on box, and I strongly encourage you guys to store all of your data on some sort of server that's automatically backed up. Several times students lose their code, lose whatever files they're working on, but if it's automatically backed up, you don't have to worry about that anymore. So make sure you're storing your files, your homework, whatever you're working on box, on drive, whatever you have access to, just as a best practice in today's society. So I'm in box. For this class, I store everything in AAA EAS 230. I name it AAA because then it shows up at the top, and I have a lot of files, folders in box. And then for me, for this semester, I'm in 2020-01. And then let's say I wanted to get to this specific file for the notes. This up here at the top shows me all of the folders I went through. I went from users to EH32 to box to AAA EAS 230 to 2021-01 to lectures. That is the path. This is the path to this specific file. And this is relevant because in MATLAB, there's a lot of discussion about a path and where your files are stored. Okay, so I wanted to highlight what a path is. Okay, so that's just some basic background information on a computer, which most of you guys already know. But let's go ahead and talk a little bit about programming and why we are programming in MATLAB for this class. So computer programming in general as a practice, it's used to do a lot of things. For engineering, specifically, it's used to solve complex, technical, mathematically dense problems. Not everything can be solved by hand, or at least in an efficient time, or in a physical time. So we use it to solve complex, technically dense problems. It's also practice for precise discipline and abstract thinking. I mentioned on Monday, I believe I mentioned in your class, that programming tends to be challenging because it's a different way of thinking. It's not just like math, it's not just like writing a paper. It's a different way of thinking. And so we are practicing our problem-solving skills by doing programming. Also, it allows us to turn our computer into a powerful tool and then practice for learning itself. There are lots of different programming languages. In general, a programming language is just a set of instructions. They're sent to a computer and they tell it how to behave, what to do. The computer itself really only speaks in binary and those instructions that work with binary. We're not going to write binary, which is great. But there are a specific set of instructions. We are limited in what we can do. We can create variables, which I'll get to today. We can do selection using branching. We will get to that in week 5 or 6. We can do repetition, where we repeat the same set of instructions over and over and over again. That's looping. We'll get to that after branching. So there's a specific set of things we can do. We can't just do anything we want. We are limited in what we can do. That's what makes programming challenging. You have to take this problem and figure out how to solve that problem given your set of instructions. There's lots of different programming languages that exist. Some of the more common ones would be C, C++, Java, JavaScript, Python. Those are some of the more really common ones. MATLAB doesn't reach the really common ones when it comes to programming as a practice. But MATLAB is really strong for engineering computations. So you really choose the language that best suits your application based on its strengths and weaknesses. Python is something you might choose if you're doing machine learning. JavaScript is maybe what you choose if you're doing web development. Java, I don't know. Java is like the stepchild that everybody is related to. C++ and C, maybe you would want to use those if you're much more concerned about memory management and how fast your program is running. C is really common for embedded systems. So you really choose the language that you best suits your application. We are choosing MATLAB, and MATLAB is a computer software, so you guys all installed the nice MATLAB software program, and it's a programming language that's used to perform engineering and scientific calculations. Specifically, MATLAB is used for linear algebra. And so inherently, it's essentially numerical analysis and computations is the inherent language of MATLAB. So it's really great for engineering, especially for the disciplines that you guys have. It's not necessarily widely used in all the disciplines, but it's highly used in your disciplines, which is why you have to take this class. The nice thing about MATLAB is it's nicely packaged, so it's all in a program. You double click that MATLAB icon, it opens, you can immediately start working with it. That's great. It integrates your programming, your computation, visualization, all in one nice compound package. It's a very big package, but it is just one package that you're working with. It's also cross-platform, so it doesn't matter if you have a Mac or a Windows or even a Linux machine if you have one of those. Another nice thing about MATLAB is it's weakly typed and interpreted, which really you guys don't need to know what those mean, but really it makes it accessible. We can run one line of code at a time. We can use it as a, prototyping. It's used a lot for prototyping. Like we can check to see, okay, what does this do? If I did it this way, I can immediately see what's happening. So that's convenient. It makes it very accessible. There's also a lot of pre-existing code that MATLAB already has built in. You guys all learned or saw a bunch of different toolboxes that MATLAB has that you can use. All of that is pre-existing code that someone else who's smarter than us wrote that we can use to do really complex calculations without having to worry about writing it ourselves. So that's some basic introductions to programming and why we are using MATLAB. So let's go ahead and start. So let's go ahead and open up MATLAB. So if you look here, you literally just double click the program and it opens. And it looks something like this. Yours probably looks something like this. So what you see here are some separate windows. So each of these windows are named. So I have a current folder, I have a command window, and I have a workspace. You might have some extra ones. You might not have all of these. If you want to look just like this, you just go to Layout up here at the top, and then you click Default. So I did the default layout. You can follow along in MATLAB if you want. That's completely up to you. These videos are posted. Really, if you want to just take notes on the notes, that's fine. If you want to follow along, that might be useful. Maybe you muscle memory, like, oh, I remember I did it this way, helps you pay attention more. It's really up to you. We're not going to get too involved today, but that's up to you. You can get involved in or follow along in MATLAB or not. Just keep in mind, MATLAB might be slow to open depending on how fast your computer is. I've had MATLAB open all morning, so it's just nicely popped up here for me. Okay, so let's talk about these windows. So this whole thing that you see here is the MATLAB desktop, and it's composed of a bunch of different windows. The current folder is literally just your file structure. Here's my path. So the files seen here are in the users folder. In this computer, not my laptop, it's the Emily Hammond is the user on this one. In the documents and in MATLAB. You guys all have this folder that was installed on MATLAB. So these are the 3 files that are stored in this location. And you can navigate through it just like you would. So here's documents, all that fun stuff. And so this is the path to whatever you see here. Then you have the command window. The command window is essentially it's a scratch pad. You can type lines of code in here one at a time. It's going to display your output. It's kind of like the just jack of all trades, and we'll see how we interact with the command window as we go along. That's a good question. AP Cruzy. I will mention that in a minute. And then over here is your workspace. Your workspace is going to show all of the data that your program is working with. If you want to use MATLAB Online, that is completely fine. So MATLAB Online looks a little different and it behaves a little different. It's not perfect. It's not exactly a one-to-one, but it's very similar. So here's MATLAB Online. This is what it looks like. You have your current folder, which ties into your online MATLAB drive. Here's your command window. Here's your workspace. So it looks similar on MATLAB Online. It is a tiny bit different, but you can definitely use MATLAB Online as well. Okay, so there's a couple other windows that you will interact with. The first one is your command history, which if you go to layout and you see the drop-down menu, at the bottom you'll see command history, and if you click on the arrow, it'll say, you can click docked, and it'll show your command history. It might be useful, it might not. You can always get rid of a window by clicking on the arrow icon, and then you would hit close. I know those windows don't pop up, but you would hit close. Another window that you're going to extensively be working with is the editor window. So if you are following along, go ahead and click New Script. New Script opens up the editor window, and I'm going to change my layout. So I go back to the Home tab, change layout, click my default. So now this is my default. So I've got editor, command window, workspace, and current folder. This is the default layout. You can always change up your layout as well. I like things to be in different areas depending on what I'm doing. I don't like this layout, so I can manually change it. I want my workspace to be moved under my current folder. So if you want to change things manually, you can just click on the blue bar. So click on this and just drag it. And then you can click to wherever you want it to go. And then I want my command window to go next to my editor. So I'm going to click it, drag, and move it over. There we go. So this is how I want things to be laid out. So you can always lay things out as you want them to be laid out. That is completely up to you. You can always change your layout by using the layout icon or the layout option up here, or manually moving things around. Like I said, I like to move things around in order to fit whatever I am doing. Okay? As you get more used to using MATLAB, you will get used to how you want things laid out. Same thing in MATLAB Online. It's a little clunkier. Doesn't always move exactly as smoothly as the desktop application, but same idea. Okay. So in the notes, it's useful commands. I will skip those and go to writing our first program. Okay, so in this editor, like I said, you're going to be working extensively with the editor. The editor is where you can type your code. This is where you will write your programs. So I'm going to go ahead and write our first program. I'm going to copy the code directly from the notes into here. So mass equals 1400, vel equals 30, and then ke equals 0.5 times mass, times vel squared. So here we go. Here is the first program. I write it in the editor because in the editor, what I can do is I can save this code. So there's a couple ways you can save it. If you go to the editor tab, you can click save, or you can press run. But let's go ahead and save it. Let me just save it as something code.m. A couple things about your file names. So here I have this, I saved it as code.m. You can see the file name right here. And note in my current folder, I now have a new file called code.m. So I can close this out. Note my editor window disappeared, and I can reopen it and my code stays. So a script file allows us to save our code, so we can save it for later, which is really useful. We can then modify our code and work with it. If we write, we can also write code in the command window, but we can't save our command window. Okay, so it's really useful to write your code in a script file. You really could write code one at a time in your command window, and it will execute each line as you go along, but you can't save it. Like, I can't go back and I can't edit this. I can't say, I want mass to be 1200 now. You can't do that. Whereas if you're writing the script file, you have the ability to do that. Okay, so your homework, pretty much everything, you will be writing things in script files. Okay, so let's look at what is happening in each line of code here. So notice in this code, you don't know what it's doing, but there's a lot here that's some pretty basic stuff that we need to go over for programs. So we have this word mass equals, and then a number. This word vel equals, and then a number. This word ke, or these letters ke, equals some sort of mathematical calculations. 0.5, asterisk, word, asterisk, vel, caret 2. These words here, mass, vel, ke, these are what are called variables. So a variable is just a named location in memory. Think about a variable as a container. And I brought some mason jars here to illustrate that. So a variable is just a container. It is used to store information. Right here is a semicolon. Notice each line of code has a semicolon. That's not required, but it is highly recommended. I'll get into a semicolon maybe today, maybe Monday. But a variable is just a container. Thank you, space engineering student. Perfect. So a variable is just a container. Think about it as like, here's my mason jar, okay? A variable name is just naming this container. So this container, I might call it mass. A different container, I might call vel. And a different container, I might call ke. Okay, it's just used to store data. Names of variables, there's only certain things we can use to name your variables. So let's go ahead and go over those rules. So you have a lot of freedom to name your variables. However, you can only use letters, digits, and or underscores. So I can name my variable mass vel ke. It's just letters. So keep in mind, variables cannot begin with a letter. I cannot say 3 stars. That is invalid. And variables cannot have spaces, so I can't say 3 stars. And MATLAB will give you an indicator because it tells you more or less that there's an error. So here, MATLAB says there's an underlined red. It also shows up over here that there's an issue. And it says there's a parse error, and we'll see what a parse error is probably on Monday. Okay, but here it's just saying, hey, there's something wrong here. Same thing here. I could have just 3, but stars isn't a part of my variable name, and MATLAB thinks it's something different, so that's why it's highlighted in purple, maroon, fuchsia, one of those 3 versions. Not maroon, purple. We'll just say purple. Okay, so these are invalid variable names. We can only use letters, numbers, and underscores. They're also case sensitive. So that means if I have a variable named mass here, and I used capital M, mass here, these are 2 completely different variables. So lowercase mass and uppercase mass are 2 completely different variables. A common error with students is misspelling something. So there's no spell check in programming, because really, who cares if you misspell a variable, as long as you misspell the word every single time. So keep in mind, variables are case sensitive. So if you type MASS all lowercase, it needs to be MASS lowercase the entire way through your program. Those are the rules with naming variables. There are a couple conventions. So like I said, you have freedom to name your variables more or less whatever. But there are some conventions. So for example, if I wanted a variable to store the number of people, I might call it number of people. And remember, I can't use spaces. I can only use letters, numbers, and underscores. I can't use symbols. Someone asked that in this morning. I can only use letters, numbers, and underscores. So typically what we do is we use something called camel case or snake case. Camel case looks like this, where if we're creating a variable name that combines a bunch of words together, we just start each new word with a capital letter. Snake case is where we replace the spaces with underscores. So I could say number of people. So in line 3 here, I have a variable called KE. You might have guessed it's for kinetic energy. It stores the kinetic energy. I could replace it by saying kinetic energy. That would be snake case. Or I could say kinetic energy for camel case. Either one is valid. And there's no one way to name your variables. A lot of times you use a combination of both, and everybody really develops their own style, and that's completely fine. In your homework, I will tell you what some of your variables need to be named. If I don't tell you explicitly, you can name variables whatever you want. The last thing is that variables, you have a lot of freedom. There are certain words, though, that cannot be used for variables. These are called keywords. And these are listed out over here. So break, case, catch, class def, continue, etc. These words cannot be used as variables. And you'll notice that in MATLAB, they typically show up blue. Okay. So you can't use case, but you could use capital case. So note, these are two different words. Okay, those are the rules with naming variables. Let's get back to this code. One other caveat is your script file names, when you save your files, they also follow the same rules as naming variables. So I can't say code space week 1. It's the same rules for naming your files as it is for naming your variables. And then we want to make sure we use descriptive variable names. So you might guess mass stores the mass, vel stores the velocity, and kinetic energy stores the kinetic energy. Okay, so that's the first thing. These words here are variables. They are just containers with names that are used to store values. Okay, so let's get into what this equal sign means. In math, the equal sign means equals. If you say x equals 5, that means x always equals 5. Like that is static. That is always the case. In programming, this equal sign is known as the assignment operator, and it is used to store data inside of my variables, inside my containers. So this statement here essentially says store the value 1400 inside of the container called mass. This line here says store the value 30 inside the container called vel. And this says store this calculation inside of the container called kinetic energy. So the equal sign is just assignment. It's saying store a value inside of that container. So let's go through a basic example with my beautiful containers. So let's say I have two variables, one called num, it stores the value of 2, and one called var, which stores the value of 9. So give me a second. Here we go. I have two variables. Here's my 2. Here we go. Here's my 2. So this jar is nicknamed num. Here's my 9 in my jar nicknamed var. And let's say that I want to switch these values. So I want 2 to be inside of var and var to be inside of num. So Shnatuba, no, you cannot edit anything in the command window unless you retype the line of code. You just retype it. Okay, so if I had a statement that then follows out and says num equals var. So here's var, here's var, here's num. So if I then said num equals var, what that means is whatever num stored is going to be completely thrown out. It's going to copy whatever was stored in var. So now they both store a 9. And so in line 5, this was my situation. I have a 2 and I have a 9. Or in line 5 and 6. In line 7, though, I have completely taken out the 2 in num and stored a 9. Line 7 essentially says, take whatever was stored in num, delete it, and replace it with whatever was stored in var. So now they both store 9s. Note, I cannot get that 2 back. So any lines of code below here, I cannot get that 2 back. That 2 is completely gone. It is deleted. This morning I threw it behind me and I lost it and I found it after class. But it is deleted. I cannot get it back. So if you are trying to swap 2 values, if you're trying to take the 2 and store it in var and the 9 and store it in num, we need to introduce a temporary variable. So temp would store num. So now, initially, in line 5, I have this situation. In line 9, I have this situation. In line 7, I created a new variable called temp. So I have a new container. And what it did is it stored the value that was stored in num. So now temp also stores a 2. It took whatever num had stored and copied it in. So now in line 8, it took the value in num, or in var, it took this 9, copied it into num. So now num and var both store 9s. So now num stores what I want it to store. And my last thing is to take var and put my 2 in from temp. So now var got rid of the 9, and now it stores the 2. So now I switch their values. So keep in mind the assignment, the equals, means delete whatever was there. You have no longer access to it, and replace it with whatever shows up on the right-hand side. Okay. And you expect to do that. You expect your variables to change over time. Okay, so question, why is there a red line under num? So there isn't anymore. Anytime there's a red line means that there's some sort of error that needs to be fixed inside of your code. So, I don't even know how to make an error under num again. But anytime there's red that shows up, it's MATLAB indicating, hey, there's something wrong. So Benny Levin says, so you can't do var equals num. So you can't do var equals num anymore because it uses the last number. So the last number that num stores was from line 8. And in line 8, num stored an 8. So here, num stores a 2. Here, var stores a 9. Here, temp stores whatever num stored, which was a 2. Here, num is replaced. Num is replaced, the 2 was deleted, and now num stores a 9. So here, when I use num, it's going to use the value from num from the most immediate line before. So it's going to use this one. This one is no longer accessible. It's as if it wasn't even there. Yes, it is chronological. It's called, it's sequentially executed. I will talk about that on Monday. But yes, that's exactly the right idea. Awesome. Okay, so keep in mind, equals is assignment. One other thing to note is the way we write our code is we always have variable equals something. We can't have something equals variable. This is invalid. See, there's red there now. It means that there's some invalid stuff there. Okay, so we always do variable equals something. This is going to be evaluated first, and that's going to be stored inside of whatever shows up on the left-hand side. Okay, so that is assignment. Keep that in mind. That is one of the harder things for students, for beginner programmers to comprehend, understanding what are variables and what they store and the fact that it changes as we go through. And you'll get used to this. You will get used to this. The more you write code, the better you will be at understanding what's happening. Okay, so let's talk a little bit about what is happening on the right-hand side. Okay, so we talked about what variables are, what they store, what they represent, all that fun stuff. Let's talk about what happens on the right-hand side. The right-hand side is called an expression. An expression is going to be a combination of literal constants or values, like numbers, 1400, 30, 0.5, 2, along with variables. So here mass and vel, and then operators. So here multiplication sign, exponent sign, and then also function calls as well. So essentially what we're going to do on the right-hand side is we're going to perform our calculations. So when I get to mass equals 1400, velocity equals 30, we already talked about what those mean. When I get to kinetic energy, what it's going to do is it's going to do this calculation. It's going to say 0.5 times the value stored in mass times the value stored in vel squared. It's going to do that calculation, store the result inside of kinetic energy. There are lots of different mathematical operators we can use. The main ones, or I guess the ones essentially would be exponent for exponential. Multiplication is the asterisk. Note, anytime you do multiplication, you need to have the asterisk. If I just did 0.5 mass, there's an error. So it says a parse error at mass. It doesn't know what you're talking about. Okay, so you can't just say 0.5 mass. You have to do the multiplication sign. And that's a common error with students, forgetting to use the multiplication operator between two values or two variables. We also have division. So division is just our normal division sign. So there's right division, which is the normal division. There's also left division. Don't worry about left division until we get to until a couple weeks. Okay, so just normal division, and then we also have addition and subtraction using our plus and minus. Those are our mathematical operators. Okay, so I'm gonna go ahead and stop there for a minute, and I'm gonna go ahead and run this code. So I have 3 lines of code here. If I want to execute the code, I'm going to go to my editor tab and press run. When you press run, what happens is it's going to execute these line by line. So note, I have 3 variables now, mass, vel, kinetic energy. Those 3 variables show up in my workspace. So I now have a variable called kinetic energy. I can see the result that it stores. It stores a value of 630,000. Mass stores a value of 1400, and vel stores a value of 30. Keep in mind, your computer just stores numbers. It has no idea what units you're talking about. So when you write your code, it's important that you understand what you're doing. So what we can do is we can use comments in our code to give some context. So comments are written using the % sign, and then we just type whatever text. So the purpose of this program is to calculate kinetic energy. It's a little more complicated than that, but calculate kinetic energy. Give it some context. I can identify that the mass here listed is in kilograms. The velocity here is listed is in meters per second, which means that if those are my units, this would be in joules. You can always change this code whenever you want. So here I save it. I can close out of it, reopen it, change it, do whatever you want. However, anytime you change your code, you need to save it before you run it. Thankfully, in MATLAB, when you press run, it automatically saves your script file. MATLAB Online, it's not that sophisticated, which doesn't make any sense to me. So you need to make sure that you save your code in MATLAB Online before you click run. I don't know Java. System out print. I think is that printing things out to the screen. We will get to printing things out to the screen in week 4 or 5. The nice thing about MATLAB is we don't really care about printing things out to the screen right now because we can see in the workspace. We can see explicitly what values are stored in our variables. I don't need to print out the value of kinetic energy after I calculate it because I can just see it in the workspace. So steel belted, yeah, so you can change whatever you want inside of your code. So if I wanted to change this variable back to KE, I would just change it back to KE, I would run it again, and my code is saved. Okay? Let me undo that. So note comments help give us context. Okay? Note, when you're writing your code does not know what you want it to do, so you have to make sure that you are explicitly telling it what to do. Okay, we've got 10 more minutes. Let me point out some stuff. So when you're saving your files, save it in whatever you want your current folder to be. So if you have an EAS 230 folder, just navigate to that using these. So if I wanted to go to where I have my EAS 230 folder located, I would just go into Box, EAS 230, whatever. So wherever you want to save it, just make sure you, like if I ran my code now, it would give me, oh, nope. Weird. I would think it would, oh no, never mind, it's in the MATLAB folder. But just make sure it's in your current folder. Let me go back to my MATLAB folder. You can make a folder here if you want. You can just right click, new folder. This is literally how you interact with your files. So if it behaves exactly the same. Anything you do here will be reflected inside of Finder or your File Explorer. If you try and run something that's not in your current folder, it will say, we can't find it. It will give you a couple options. Just make sure you navigate to wherever that file is stored. Just keep everything in the same spot. And you'll see as we go along how that plays out as well. Okay, a couple other things to mention. We can do more complicated, let me go back to the notes. We can do more complicated mathematical calculations using built-in, where's my pen? Built-in MATLAB, what's called functions. It essentially allows us to do more complex mathematical calculations. For example, if I had some calculation, if I wanted to calculate the function y equals 10e to the x, where x equals 5, what I can do is I need to translate this into programming language. So I would say, whatever I name my variables, x equals 5, semicolon, y equals 10. To calculate e to the x, I would say multiplication, and then use the built-in MATLAB function that does e to the x. So if I go to this table, e to the x is calculated using the exp. So I would type exp, and then inside goes my x. Similar to how you would do it in your programming, your scientific calculators, your programming, scientific calculators, whatever they're called. But you just need to translate your mathematical notation into programming notation. So if you have a square root you need to calculate, you would use square root. If you wanted to do a trigonometry, if you wanted to calculate sine, you would have one of two options. If you are working in radians, you would use sine, cos, tan, a sine, a cos, a tan. If you are working with degrees, you would add an extra letter and just say D for degrees. So the harder ones that students need to remember is exp. It's not just e raised to the whatever, like you need to use the exp function. Same thing for, not same thing, but similarly, natural log is just log base 10. So this is log 10, uses log 10. So make sure you're using the right functions. Other things I want to mention is MATLAB has some built-in variables. So here's some built-in variables that it has. Ants is the default variable. So we mentioned that its variable equals expression. Spelled incorrectly, but that's the idea. You do not technically need this. It's best practice to have it, but you don't technically need this. You could just say expression. If you just type an expression, it will automatically be stored in a variable called ants. There's also pi. Pi stores the value of pi. So if you have to calculate sine of pi over 3, you would just say sine, parentheses, pi, divided by 3, close parentheses. I and j are the imaginary number, I and f is infinity, and an is not a number. So one of the big things is converting your mathematical notation into programming notation. So Jay asks, can we do logs of other bases? You can. I did not put that function here. There's a different function to do that. You can Google MATLAB logs of other bases. So yeah, you can. I just didn't write that function there. Should we wait until Monday to start the homework? If you want to, you can wait until Monday to start the homework. You do not have to. You can try and figure some stuff out as you go along. In your homework, you're just going to need to open a new script file, which we already did today. Save it. I tell you what you should save it as, what the name should be. And then you just write a bunch of mathematical expressions. So you can start it, not start it on Monday. I'm also going to show you the different resources you have available to test your code. So if it's up to you on when you would start. It's due Wednesday. You allocate your time as you see fit. The notes pages are already posted on UB Learns. I'm not going to post the annotated versions because I'm not annotating it that much. And also I annotate it slightly different depending on whether or not it's 9 a.m. or 11:30 a.m., G or H. But you can annotate, you can type right on it as we go along. Okay, doing a derivative would be fun in MATLAB. So it would be fun in MATLAB. You can't just, there's no, well, there might be a derivative function. I don't know. You can Google that, see what it looks like. Okay. Last final things to mention are some useful commands in MATLAB that you can use in the command window. So if I go back to MATLAB, notice when I run my code, in the command window, it lists out the name of the file. So it lists out, hey, I ran code. These semicolons are used in order to what's called suppress the output. And you'll see MATLAB has this warning here that says, hey, are you sure you want to leave a semicolon off? So if you press run here, now the variables or whatever values are stored in variables are automatically printed out to the command window. Another reason why we don't need a system out.print right now. There's automatically a default printout. And all of that printout goes to the command window. So typically, best practice is to put a semicolon after most lines of code so that you don't have a bunch of clutter in the command window. If you ever want to clear the command window, if you want to just kind of delete all of that text there, you can just type CLC. CLC will clear the command window. If you want to, let's say you are trying to debug and you're just trying to start from scratch, which means you don't want any of these calculations, you don't want any of the data in the workspace anymore. If you ever want to clear the workspace, you can type clear and it will clear the workspace. Another thing is format. We will get to format a little bit later, but format indicates how things are printed out as how numbers are printed out in the command window. And then diary is something you can use to record the command window to a text file. I'm not gonna go through that one. So Shnatuba, when do we use EPS1? So EPS is epsilon. It's essentially the smallest difference between two numbers that a computer can store. To my knowledge, we're not going to need to use that. At least I don't have any use for it. I've never used it at all in my practice. So it depends on your application. But to my knowledge, we're not going to use that as a number. Okay, so let me look through the notes one last time. I think we covered it all. I did not go over what a function is. I will talk about that in the videos that you guys will watch on Friday. So that is it for today. We covered a lot. So I tried to make today a little more practical. Hopefully you guys found it useful. Like I said, your homework is posted on UB Learns. It looks, nope, that's not right. It looks like this. So here's the instructions. I will go through these instructions on Monday. I will outline how I expect your guys' homework to look, how you should submit it. I will go through MATLAB Grader and invite you guys to MATLAB Grader earlier in the day so I can show you how to use that. But notice homework, you're just doing a bunch of calculations. You're not even really dealing with variables other than storing your answers in variables. And same thing for problem 2. Okay, I'm gonna stick around for a little bit. Whoever asked that question, I can't remember. It was a blue username. You can ask your question again, but I will stick around for a little bit if you guys want to ask questions. Other than that, have a great day, and I will see you guys next Monday. So Nick, saving your files should just be saved in your current folder. Note, in my current folder, it's the MATLAB one that's in my documents. You can choose wherever you want to save your files, just as long as when you run them, it needs to be in your current folder. Cupcake Panda, you can just close out Twitch, I think. So yes, Shnatuba. So Nick, if you want to save it to UBbox, Shnatuba, I will get to your question in a little bit. Nick, to save it on Box, you just navigate through the files up here. So if I go to users, me, I can navigate to Box, navigate to wherever file I have. Wherever you want to go. So if you want to open up your file explorer, how you normally interact with your files, you can always copy and paste things over. But like interact with your current folder as if you do your normal file explorer. AESTROZE. MATLAB. So Python has really grown recently. A lot of what you can do in MATLAB, you can also do in Python, especially with the NumPy library. But MATLAB's been around. I mean, it was built for processing matrices. There's a lower in Python. I haven't extensively programmed in Python, but like, I mean, everything's nicely packaged in MATLAB. MATLAB also has MathWorks also puts out Simulink, but really a lot of what you can do in MATLAB you can also just do in Python. It's just what is your familiarity, what is your comfort level, the initial use of MATLAB. It's a little more accessible than Python. Okay, so Shnatuba, Crew, APK, go to the website. It should tell you how to activate MATLAB. That link that I sent you, you should figure out how to use that to activate. I think you need to create an account with your UBIT name and password. If you can't figure it out, contact UBIT. Wilcox, I will let you know those resources when on Monday, when you have access to MATLAB Grader. MATLAB Grader, you'll be able to check your numbers. So Shnatuba, let me open up the textbook and see what one you're looking at. So Pat Fallon, it's really up to you. I would recommend you do that to some extent because the textbook is in smaller chunks and the homework is in a little bit, it's a little more involved, but it's really up to you. I mean, the zyBooks are due before the homework, so in terms of timeline, yes. Accuracy. Sorry. So, Shnatuba, I'm looking at it. So this section really focuses on the fact that computers are finite. They can't store an infinite number of decimal points. So when you type 1/3, you get 1.33333 infinite repeating, right? Or yeah, 0.333 infinite repeating. It can't go on forever. Like there's some chunk, like at like 16, 20, 32, however many digits past the decimal place, it stops. So that means that there's going to be some errors in your calculations. So it's going to store as much as it can, but at some level, there's going to be an inherent inaccuracy in your calculations. The rounding error is, it says it's the difference between the calculated approximation of a number and the exact mathematical value. That difference between that infinite calculation and where it cuts off. I mean, like I said, it cuts off pretty far. But since it is rounded more or less at that 16th digit past the decimal point, there is some error in your inherent calculation. It's not going to be exactly the mathematical value. In my grad lab, one of my friends, she had in her whiteboard, it was 0.3 is not equal to 0.3. And that's because of that error. So the way you calculate 1/3 one way might be different from the way you calculate 1/3 another way, depending on how you got to that calculation. So no, you're not going to have to, so you're going to have to account for this a little bit. I'll talk about that when we get to, I think week 5 or 6, when we get to comparisons. You're going to have to be slightly aware of it. You'll see it a little bit in your first homework when you're comparing, when you are doing the, oh my gosh, brain. When you're confirming the trig identities, you're going to see some differences in the left and right, but you're going to notice it's a really small number. So some of them are going to be 10 to the negative 16th. Some of them are going to be 10 to the negative 8th. So just identifying why that is, that's what accuracy and rounding error is focused on why don't you see 0? Why don't you see that exact calculation? Because you can't, because computers are finite. Does that help clarify some stuff? Okay, good. Some of the stuff in your textbook is more to give you context. It's not something we're necessarily going to do explicitly in class, but it's context on why things behave the way they behave in programming. Okay, so if there are no more questions, I am going to head out and see you guys on Monday.